We are in IoT 2.0 and moving fast into IoT 3.0. IoT 1.0, the first wave of IoT, was about sensorization and measuring and tracking. Call it the Fitbit of industrial world. The IoT 2.0, which we are in right now, is about that brought in remote monitoring, understanding the data. And the gains of that were humongous. At the turn of the decade, GE projected that 1% efficiency in the industrial internet was worth $1 trillion. 3.0, or the third wave of IoT, is going to bring the real potential. Think about autonomous operations, where systems are operating by themselves. That's what IoT promises. Just imagine an operations unmanned operation where there is your network is fully aware of redundancies and risks. That's what IoT 3.0 is. So the question would be, how it's going to happen? We believe that the advancements in artificial intelligence and technology will be coupled with the deficiency of the technology. Our behaviors are going to change, and we'll start producing data to overcome the deficiency. So it would be a confluence of the technology and our behaviors. So let's say, take an example. Today, a lot of our clients say we don't have enough data. And machine learning algorithms, which are hungry for data, need data. So what's going to happen? Techniques that fare really well with limited data within artificial intelligence are going to emerge. But on the flip side, we'll stuff industrial assets such as, for example, Siemens turbine. The new ones have 3,000 data points. That's enough to be able to do a lot of smart thinking. Natural language processing is a tough problem, as Professor Porter mentioned in his session as well. So there will be advancements to understand natural language, the ambiguity, as well as the variability in the natural language. Consider this for an example. If today you teach a system that vegetarians eat veggies, and then ask, what do you think humanitarians eat? And look, there will always be ambiguity as long as there are politicians and lawyers in the world. But as our behavior changes, we'll start speaking and understanding languages. Just look at our behavior with Alexa or Siri. Or we have learned and evolved to tweet in special characters. There's already a notion of controlled natural language. That means English with very limited ambiguity. And that's what will also help us get there. Similarly, our human-machine interactions are going to change. There will be corrective systems within the learning. Today, we are doing supervised reinforcement learning that Professor Stone talked about. They will be learning from demonstrations and a lot of other things that will come in the system. Autonomy is here. And we're very proud to be partnering with Mitsubishi Hitachi Power Systems, who have the vision to build an autonomous plant. They're starting in IoT 2.0 and very quickly moving to 3.0. The goal here is to start with predictive, bring efficiencies of the 2.0, and then build a plant that's going to be fully autonomous. So that's the vision, how AI is going to fuel the industrial world. And I'm very proud and honored to have a very esteemed set of panelists with me. And I'd like to invite Andy Timm, who's the CTO of PTC, a large company that has a very prominent and leading IoT platform. But the roots of the company come from CAD and PLM software. We've been working with them, and somebody I believe who understands the technology as well as the business part of it. And I don't know many people who know IoT better than Andy. So welcome, Andy.
Thanks, Usman. Thank you. So if I seem distracted, I think I'm still trying to figure out where I fit on the Venn diagram of career choices and nerdiness. So though I can barely see people, can I see a show of hands? Who's ever heard of PTC before? Okay, many of you. Of those people, which know us as CAD and PLM? And then which know us as IoT? Okay, final question is, how many people think it's crazy that a CAD and PLM company just spent about $1 billion on IoT and maybe don't understand the interesting overlap there? So that's kind of what I'm going to talk about real briefly. And this is best shown in our new logo. So PTC is really about the convergence of the physical and the digital worlds. So if you kind of twist your head a little bit, you see a P on the top and a D on the bottom nestled together in this yin-yang symbol that worked out kind of nice. So within yin-yang, this is this Asian symbol that two kind of competing forces that complement each other, so man and woman, hot and cold, night and day. We kind of see this with connected products. So our legacy is using digital tools to create physical products, and then now with ubiquitous network connectivity and inexpensive sensors, we can bring data back from those physical products and marry them together with the digital information that kind of birthed that physical product and do all sorts of good stuff with analytics and AI. And you see AR on our chart. We at PTC think that IoT and AR kind of go together like peanut butter and chocolate. We use IoT to get the data from the physical world into the digital, but then use augmented reality to put the digital information back on the physical. That's maybe a talk for another time. So this plays well in the factory as well. You've got, all sorts of things that are producing data in your factory. Different assets in the line, lots of PLCs, but there's also enterprise data in your MES system, ERP system, data historians. And if you really want to do, this IoT 3.0 that Usman was talking about and realize autonomous anything, you need to talk to all of those things and get all that data in and available to your AI engine. So how do we do that? At PTC, we call this an industrial innovation platform. This is more than an IoT platform, and I'll just quickly run through this chart. We start with sourcing. We need to get data from PLCs and historians and the sensors themselves and maybe that tractor and a MRI machine. If you've already got data connected with an IoT platform like Google Cloud Platform or Amazon or Microsoft, that's great. You're connected. We'll take the data from there. So now that we get data coming in from all of these disparate sources all over the place, we need to put it in context. This attribute is the vibration from that pump, and this is the cost from ERP, and we put that all together kind of in a software representation of this real-world asset. So get the data, put it in context, and now synthesize the data. And this is where these amazing AI tools, like what SparkCognition has, but also simulation tools. So go find some information in this big collection of data that you might not find with your human brain. And now once you found some insight, you got to do something with it or it's kind of useless. So we call that the orchestrate, and that's where you're going to do some business process automation. When this happens, go do that. Go turn off the valve or turn up the temperature or create a trouble ticket in Salesforce or whatever it might be. And the final stage of orchestration is with humans, so we need to engage. This is where we're going to build business applications to allow people to interact with this system that we put together. So we call this the Industrial Innovation Platform. So if we try to apply this, to more of a concrete example, the product life cycle, you start by designing or engineering something, then you go make it, you manufacture it, you sell it to somebody, they use it for a bunch of time, and they probably have to serve it every so often. So this is kind of the life cycle of a product. So we dig into engineering. If I want to go start to automate some of the tasks within engineering, there's a lot of different systems in here. Like as I mentioned, ERP and CAD and ECAD and ALM, application lifecycle management. So let's overlay our innovation platform here. Now we're collecting all this data, bringing it in, contextualizing, and then finding some insight with the techniques that we've been talking about here the last couple days. So this, I don't need to go into detail, but this also exists in manufacturing. This exists in operations, and where I'm not an AI expert by any means, where I kind of spend my time and my focus is in trying to help companies realize value today. A lot of this stuff we can, you have all these tools. This is data that we can go connect. We can pull it in. We can hand it to to the machine learning tools and the AI engines. But there's a lot of kind of lower level piping that has to happen. You got to get the data, you got to put it in the right shape and size, and that's where I spend a little bit more of my focus. So I look forward to talking with you and hopefully working with you in the future, and I'll hand it off to Usman. Thank you.
Thank you. Thanks, Andy. So our next guest is John Mansfield. John is Chief Digital Officer for GE Aviation, and previously he's been the President, General Manager, CTO of the product platform for Hitachi. So very familiar with the IoT world. This is a new relationship, and I look forward to getting to know you better. Thanks.
Good afternoon and good morning. I assume everyone knows GE. It's a fairly large company. I think we actually invented the term IoT before we actually knew what it meant. Actually, I had a conference I was in last week, and it was a military DoD conference, and all I want to talk about was big data. No one actually really knew what it meant. What did big data mean? So we're going to see a lot of terms that just get floated around. But I do want to just give you a little some background on GE and why, what are we really focused upon. We had one slide that we put together that's really talking about what are the things we really care about to actually solve a problem. We have three very large businesses. We have our power industry, we have our aviation business, we have our healthcare group, then we have a number of other things that are associated with those. But where our bread and butter is really in the aviation, power, and healthcare. Aviation and power actually have a huge number of synergies. We build things that use energy and create energy, and we're really good at that. If you look at the capabilities GE has between the GE Research Center in New York, the IoT platform division, which is GE Digital in San Ramon, and then each of the business units that we actually have, there's domain expertise, there's technology, and then there are things we actually have to go solve. So we're not a general purpose play. That's not what we're trying to do. We're trying to solve the problems that we created. We own 60 to 70% of the commercial engine business in the world. So 60, 70% of the commercial airlines fly on GE engines. Keeping those things available is a big deal, and they're expensive, and they take a lot of money to maintain. We own half of the military engines in the world. We generate 40 to 45% of the power in the world on GE platforms. So when you look at what are we really good at doing, we have to get the data off each of these things. That's not a trivial exercise. Getting data off a plane, figuring out what edge actually means. Is it a data collector? Is it a data processor? It depends on the workload. Cloud is relatively general. I think everyone knows what a cloud is. You can go use a private cloud, use public cloud, use hybrid. The digital twin, I was actually interested to see that up as well. We use that term as well. Every engine that we ship today and every turbine we ship has a virtual clone. And we actually monitor those, bringing the sensor data in from the field to look at when should we do things. And I'll give you an example. We found out about 2 years ago that airplanes that flew in the Middle East needed to be washed and overhauled much more often than planes that didn't, that flew in Europe or North America. Why? The particulates. On takeoff, you're catching sand. Instead of bringing it in every, on a fixed maintenance schedule, like bringing your car in every 5,000 miles, we can actually now monitor these, predict when we actually had to bring them in, and we saved a tremendous amount of time. We cut days off turnaround times on these very expensive assets. We focus on the application layer. It's really on what we call asset performance management and predictive analytics. In our world, predictive analytics and AI are basically the same thing. And the advantage we have here is that we write algorithms that have material sciences backgrounds. We build our jet turbines out of composite material, and we continue to innovate that. Understanding how that composite material on a turbine blade is actually impacted in real time, looking at weather patterns, where it flies, all those conditions, we can actually start modeling. Some of these algorithms take our scientists months to build and to test and then to reiterate on. And the last thing we're actually really focused on is additive, the 3D printing world. The dream is to disrupt the supply chain totally. If I want to bring in engine for overhaul, and I know it's going to be in this location. I know what it's been flying through. I got all the data off that. Can I print those parts, make them available, turn that engine around, and really reduce the cost of ownership on that platform? So that's really what we're about. We're not a general purpose IoT play. We're very, we have the motto, GE for GE and then GE for the world. So we go after solving the problems for ourselves. We've taken billions of dollars of costs out of our maintenance, overhaul, and repair on our engines. We realize it's a big business. It's a $35 billion business for GE. It's worth, if you spun it out of GE, it'd be about a $150 billion company, just the aviation business. So we have to solve that problem for ourselves. Every customer I've talked to says, are you using these things yourself? And if you're not, why are you trying to engage me to do that? So part of my job is to fix the internal operations of GE, but also to enable our customers to actually leverage the capabilities that we've delivered. The other piece of these you have to really think about is the ecosystem and the domain knowledge. What are we good at doing and what are we not focused upon? Everything I've looked at so far is I have to be part of an ecosystem. I have to work with the cloud vendors. I have to work with the PTCs of the world. I have to work with the AT&Ts of the world, et cetera. And we have to share data. My friend here is from Honeywell. We have to figure out how do we exchange data in a safe, secure model, allows the customer to own it, but us to extract data, information value from it. I'm looking forward to the event where we actually talk about data rights, privacy, and who owns these things, and how is that data processed. That is a serious challenge in the world, and the security aspects. So all of this is going to be great and going forward, but we have to figure out how we're going to solve those problems going forward. So I just want to give you a quick overview of what it is about GE that's interesting. I've only been here 5 months. My first career, I was actually a pilot, so I kind of went from pilot to IoT to manufacturing back into aviation. So it's been an interesting circle. But I think the amount of investment that's going into this and the amount of focus in this area is really going to change the world, as Usman, and I fully agree with everything I've seen so far in the discussions. So I'm going to turn it back over to Usman, and we're going to go on to our next speaker. Thank you.
Thanks, John. Thank you, John. So next speaker is Mobeen Khan. He's AVP and responsible for the industrial and enterprise IoT for AT&T. I've known Mobeen for some time. He's a true technologist. He has held many roles at AT&T Singular, but he's an entrepreneur as well. Somebody who understands technologies and has a passion to take things to market. So please welcome Mobeen.
Good morning. So, Usman, I didn't know you were a fast bowler, so we have to meet in the field. I was an opening batsman, so we have to do that sometime. Thank you for the invite. I wanted to share, I didn't have any slides. I wanted to share sort of how, from an AT&T and perspective, and specifically from an AT&T's IoT business unit perspective, which is what I'm a part of. And I'm tasked to look sort of into the future and provide the strategies and the products that a network provider will need in the future, in this future world of IoT and artificial intelligence. So let me try to impart on what is the sort of motivation from our perspective that we see today in solving problems for our customers. I mean, we already have over 34 million connected devices on our network of all kinds of IoT use cases, from consumer to industrial to general enterprise. So we see these use cases in play every day. But essentially, there's three major sort of tectonic shifts that are happening at the same time. And we are sort of in the middle of that, and that creates tremendous amounts of opportunities. So the first one is around the fact that the consumerization is coming to workplace, and I'll unpack that a little bit later. The second is that the rate of change of the technologies that we all work in is accelerating. So there's this second derivative effect of this acceleration that is putting a death to what engineers call continuous improvement. And I think there's a sort of a change in the way we think about products. And Andy sort of mentioned a little bit of that on how they're helping companies into that second big shift. And then the third is the human element. The humans, us that work in this, and how we work and how we engage with machines and systems around us is fundamentally changing. And it's changing at a very fast rate. And I'll give you a couple of examples on that. So let's go back to the sort of consumerization effort. What is happening is we as 20 years ago, or maybe 25 years ago, new technologies were introduced first in defense and enterprise, and then they made their way into our homes in some shape or form. I think that that has fundamentally changed. You and I are now used to using technology without even thinking about it in our daily lives in homes, whether it's talking to a smart object in our homes or doing things with our phones that we never thought of in 20 years ago. And we expect when we go to work to have the same kind of an interface at work. And then when we don't, we feel very frustrated. So that's a trend. And I'll give you an example of that. So last week with Amazon, we launched an AT&T Amazon button. And if you're familiar with the dash button where you put it next to your dishwasher or something, you run out of the dishwasher liquid, you press, it's connected to Wi-Fi, and a new order shows up at your doorstep next day. Similar idea on the enterprise side. Why can't I put a button which doesn't have to really go through Wi-Fi, just put it there next to a printer in my office? And if somebody needs to go service this, I press a button. Or facilities in the bathroom where somebody is managing my facilities can press that button, and it has an impact where a message goes to Salesforce.com or any other ERP system, creates a trouble ticket, and somebody shows up 15 minutes later. Even better, there's sensors that tell me without the button that something can happen. But Usman talked about this 1.0, 2.0, 3.0. This is a 2.0 solution where we are taking a physical action, taking that consumerization that we're used to, and getting instant satisfaction and instant service around that. That trend is tremendous. Another example of that is we have an innovation center in Plano, Texas, in Dallas, and we have customers coming in all the time talking about all these use cases. If you walk in there, you'll see a porta potty in there, okay? And you say, what is that doing in an IoT center? And there are huge companies that are in that business trying to figure out what is the automation in their business. And so that whole consumerization aspect of instant gratification, whether it's that or a connected cooler or a connected car, those aspects we are now in the process of converting them into connected products and seeing the benefits of that. The second trend I was talking about is all around this sea change and the rate of change that is accelerating. In the engineering world, many of you who come from the manufacturing industry or similar industries, the rate of change is slow. There are parts in some of these factories that are 30, 35, 40-year-old, but there's this whole mantra around continuous improvement that we talk about where we say, oh, we're going to make things a little bit better and then a little bit better and then a little bit better. But I believe that whole engineering notion has come to an end because now with the rate of change of technology, whether it's in IoT, connected products, artificial intelligence, you have to pretty much throw out what you have and start all over. This notion of how we think about products, we really have to throw out all of the investments that we may have made and start afresh. It's like going from horse buggies into vehicles. And that is happening faster and more in every industry. And it has huge impacts on how new businesses are created. So think about a Tesla car versus a normal car, where they rethought the product, they rethought the business based on what can be done in the product. And it is now difficult for the old products, not to diss any of the existing businesses, they're all our customers, but they have to fundamentally change the way they think about running their business. And that change is going to affect every single one of our industries. The third element that's really interesting is around human aspects. The human-machine interface is going to evolve completely. It's going to become second nature. Earlier this week, I was talking to a set of reliability engineers. These are people who take care of all the manufacturing shops and so on. And somebody in my panel made a statement that there's 500 people in the room, and they all are reliability maintenance engineers. And this person made a statement that there will be no need in 10 years for a reliability engineer. Think about that. That's profound to these people sitting there, that they will have no careers in 10 years. It's partially true, because if you stay into the same way as you've been doing without either changing your skill set or changing the way you interact or changing the way you do your work, you will be out of a job. And so there's huge social and political implications around that. And so we're living in a time where these three shifts make for scary times, but also make for tremendous amount of opportunities, which a lot of you in this room are looking to capitalize on. So hopefully during the panel, expect some good questions around that. Thank you for the invite.
Thanks, Mobeen. Very insightful. My last speaker is Abhi. Abhi's Senior Director for Analytics and Data Science at Honeywell. Honeywell was one of SparkCognition's early customers. We've been really glad to be working with them. And Abhi is pretty special. I've spoken to many industrial clients, and all of them claim to have some analytics in their business. But I have not found anyone who understands the business of running analytics within a large corporation as well as Abhi. And what makes it pretty special is his focus on how analytics and machine learning and artificial intelligence can deliver results. And that's probably the key to his success. Please join me welcoming Abhi.
Thank you, Usman. Really appreciate the humble introduction. This is actually the first day. Good morning, everybody. This is actually the first day I'm really feeling personally inside bad a little bit about owning an iPhone, by the way. I used to be on Android, and I made that choice, probably 5 years ago to shift to an iPhone. And today, I think I'm rethinking about some of the choices I've made in life. But that's okay. That's life, right? So we all evolve. So today, my talk is going to be more focusing on how do we deliver value from the connected aircraft, right, in IoT and aviation. Great set of panelists. Really enjoyed the conversation yesterday. Just to give you a 2-minute overview of Honeywell, we are in everybody's home from a thermostat point of view. You probably see that all over. You go to Starbucks, you scan your card, there is a Honeywell logo on it, right? So a lot of sensing devices, as well as I think that we have a ton of productivity solutions, process solutions, that goes in plants. And then we have an aerospace division. That's where I come from. So in aerospace, we have 84 product lines. We've been building hardware for more than 100 years, and we're building software for more than 50 years. So we talk about edge analytics like it's a new thing and it's exciting. But if you really look at it, the edge analytics was happening for the last 50 years when, from a flight management system, and another message comes out, right? It's just not as smart. So as we get into the IoT space and we can get more and more compute and we can get more data extracted, it just transforms the industry. Goes back from what Eric was talking about yesterday from an engine check light standpoint, so now the engine check light is much more smarter, right? So what are we doing from a connected aircraft standpoint? I mean, we are truly leveraging the next generation connectivity that we are able to bring to aviation when it comes to communicating with the aircraft before it flies, while it's flying, and when it comes down. Really making and anticipating opportunities using big data, secure communications, and analytics to really avoid weather disruptions, avoid any weather disruptions, avoid maintenance, avoid unplanned maintenance, and improving fuel efficiency and operational efficiency, and really increasing faster turnaround times for the aircrafts. So while as we get more and more connected, the aircraft is able to receive, transmit, and analyze more data, and really improve a flying experience for all the customers, as well as lower the operating cost for the airlines or business jet customers. So it's all, to me, it's all about solving problems and delivering value. And that's what I get passionate about. And then, the technology comes second as a how to enable and unlock the value so you can actually drive the meaningful conversation in industry, right? So looking at it, from a pain point, so if you want to actually go apply analytics or apply AI to the right problem sets, you need to understand what's the magnitude of the problem set. And from that point of view, if you really look at it, delays really cost airlines around $25 billion worldwide. Grounded commercial aircraft, large asset, if you listen to John, as he was talking about this morning back, how much money do we spend every day an engine is out, not going back, he was mentioning $1 million a day of cost avoidance, right? If you look at a commercial airliner being down, $10,000 an hour, that's a lot of money. Plus, you get bad reputation, you get, customer pain. But at the same time, as we get to newer aircrafts, the machines are getting a lot more smarter. They are transforming away from being analog, devices in the air to really being more digital nodes that are flying around, which are fully connected at all times. So, new 380 aircraft or a 350s has around 25,000 sensors. Take a minute. That's a lot of sensors on an aircraft, all generating data at very high speeds that is getting captured. On a 12-hour flight, 844 terabytes of data that's coming off. Now, what are you going to do with it, right? That's really the main question that is, looking at us all day long. It's like, what are you going to do with the data? Because there's still problems, there is still safety challenges, there is problems around weather. So what we are doing about it is, if you look at it, how do you use data, analytics, and insights to drive value across the chain in aviation? So from a fleet management perspective, how do you use the data we have fuel efficiency offerings where we actually get data from the aircraft and analyze what should be the right climb trajectory for an aircraft, right? So that you can actually save fuel. When you're landing, should you use thrust reversers or should you use the brakes so that you can optimize fuel? At the same time, when you're actually flying in cruise, is there a right cruise altitude so you can actually go tell the pilot, hey, can you adjust your cruise altitude so you can actually save fuel and get there faster? From a weather point of view, I don't think a lot of people recognize as I get into aviation more. So I was doing IIOT and analytics for mining. I was in Caterpillar for a long time. And then I switched to aviation. But it's interesting when you go from one industry to another industry. I can actually take a mining truck out and put an airplane in, and the problems are the same, right? When you truly think about it, it's a large asset, high cost of downtime. The biggest problem is unplanned maintenance, because that causes a lot of chaos, and how do you do schedule planning? How do you drive operational efficiencies? And everybody, they don't want reliability, they really want planned reliability, right? They really want reliable availability, right? They don't want just availability, but how can you do reliable availability? And that's where I think data analytics really truly makes a big impact, So on the passenger experience side, we are able to actually provide 10 to 100x faster internet connectivity. So you can go in. I've done FaceTime at 35,000 feet. You can browse Netflix. It's pretty exciting. That's coming. A lot of airlines have already adopted it. So improved customer experience from a weather standpoint. When you look at weather, you are looking at having the pilot is flying the airplane with a static snapshot of weather. And as they fly, and they have around 200 miles ahead of them, the weather information. But they don't have weather information real time throughout the flight segment, right? If we are able to provide that, that's what one of our services is providing. If we are able to provide that, so that they can actually avoid delays, avoid the bad weather, so you can actually avoid turbulence and get there on time and avoid delays. And especially also on the ground operation side. So I'm going to take a couple examples around maintenance and really talk a little bit about what tangibly we are doing, and then close the talk at the end. So the maintenance has two aspects. One is how do you move unplanned maintenance to planned maintenance? And then how do you do troubleshooting faster? Because you will never move all the unplanned maintenance into planned maintenance, right? So the first aspect is how do you predict maintenance? So here is an example. It's actually, these numbers come from a true customer proof point that we did, where we actually said, somebody came and said, okay, hey, our APUs are having a lot of issues. APUs are auxiliary power units that are actually, when you get in the flight, the cabin is cool, it's running the air conditioning systems, it actually starts the aircraft, and then when you take off, then the engines are on, right? So auxiliary power units have a very important role to play, and they were saying our auxiliary power units are giving us a lot of trouble. Well, it's a very reliable product. When we start looking at the data, so we look at flight schedules, we look at data coming off the aircraft, we look at flight error messages, we are looking at maintenance logs, and we are able to actually integrate it all together and start looking at it. And what we find is actually it's not the APU. It's actually upstream or a downstream component. It's actually the fuel system that's causing low fuel going to the APU. That's actually causing, but the people realize it's APU is a problem because it doesn't work. Well, APU isn't a problem. The problem is upstream and downstream. But you need to really pull together a holistic information to get to the root cause. And then we were able to build algorithms and predict, issues and write prescriptive recommendations. So you're not just telling them, that this may fail or trending information. You're able to provide the insight from machine learning algorithms to say, hey, this is exactly what's going to fail in the next 5 days, and here is what I want you to go repair. The other thing that we implemented is we actually implemented that in a very closed loop system and integrated into a customer workflow on how they actually do maintenance. So we are able to monitor when we send a recommendation, did they actually act on it or not? And if they acted on it, did it resolve? The error code went away and the failure didn't happen. In a few cases, when we go to customers, the best way to prove the value point, if they don't follow the recommendation, it's a good test for both of us. Did it actually fail or not, right? I mean, you got to stand true to the analytics outcome. But what we found is there is 35% reduction in operational disruptions, 1.5% reductions in no fault found rate, and then really a lot of improvement in the premature removals. Now, when you think about the other aspect, okay, you're bringing unplanned maintenance into plan, but there's still issues that are happening. And with a 35-minute turnaround time, imagine if you, as an expert maintainer, standing in front of an Airbus A380, giant aircraft, the biggest birds out there. It has 4 million parts, and you have 40 minutes to figure out, what part do you remove so this error code goes away, right? It's an incredible task, right? I mean, there's some really smart people out there, but every time this comes in, there is an error code that's popped out. Yes, you need to go clean this error code so that this can go fly back. There is customers waiting in line, and the boarding agents are trying to board the aircraft. Now, in 40 minutes, somebody has to go take the error code, go into the maintenance manual, and all of us are familiar with car maintenance manuals that fit in the dash, but think about an Airbus A380 maintenance manual. You can actually fill a room with it. It's like a small elephant, right? So somebody has to go in, take the error code, look into it, and then define, okay, what to replace. A lot of times what these guys are doing is they're trying to just take a part out and then put in the next part in and see if this goes away. And then take the next one out and put the next one in, and it goes away. And it goes back to what Eric talked about yesterday, is like, yes, you can over-maintain, but at the same time, you will lose, your maintenance cost is gonna be high, and then you'll leave a lot of life in the components that you're taking out. So from that point of view, we worked with Spark and Usman, and we have built we use deep NLP actually to ingest all the manuals, and we were able to provide a cognitive interface for the maintainers. So you can actually say, hey, here is the error code, or scan the error code, and it'll give you the insight on, hey, here is the next maintenance things that you need to actually go do. So it becomes a cognitive assistant, so you can actually make humans smarter, faster, better. And again, human-machine interface plays a critical role. So last but not least, as you integrate, these are some of the tenets that I go by. So really, focus on building an AI-driven business strategy to be successful in AI integrating AI into a business, and not an AI strategy. Because AI strategy is very technology-centric, and AI itself is not going to solve anything until you apply it to a use case. That we talked about applying AI to warfare or applying AI to maintenance. So you got to have the use case, you got to have the problem statement. Data is the foundation. Please secure it, because a lot of new companies getting into analytics really are very passionate about, I just want to start doing AI and ML on day one, right? This is where we want to have research centers doing it. Well, you got to know where your data is, right? If you don't have the data, you don't have a training set, you don't have anything to start with. So as much as boring it sounds, and it sounds non-sexy, but that's the key, right? You got to go secure the data. Either it's data rights, as John was talking about, or internal data. And so you got to have the data, make sure it's right, and then embed subject matter expertise with the AI talent, right? So I think a successful analytics organization really needs the domain experts. And when I say domain experts, it can be business functions like pricing, supply chain, or it can be maintenance. Those guys to understand what is analytics, and analytics guys need to understand what is the business domain, right? And they will not fully understand everything, but it goes back to the Venn diagram. right, that we were talking about. If you can get some overlap, you will get so much farther in actually unlocking the value. Select problems that have clear customer or business value versus science experiments. Integrate insights into a business workflow. So how does an insight gets implemented? Make it easy to go implement, because analytics doesn't create value. Some action that is driven by analytics actually creates value. And if it's not easy to take action, your analytics and AI capability can be as smart, but you won't deliver value. And then really establishing proof points for delivery. I think all of it really, it's great to be excited about technology and doing all these good things, but if you can't quantify value, at the end of the day, it becomes very challenging to go on, right? So make sure that as you start your journey, how are you gonna make your first success and then count your first dollar, basically, that is accountable because you did something in artificial intelligence or analytics. That part is very, very important. So with that, I think all of us are trying to figure this out, and it's every day, all of us are having these stomach bugs saying, okay, are we doing this right or not? It goes back, I think I really love this quote, if everything seems to be under control, you're not going fast enough, right? So that's something we gotta be, Mario Andretti's said it so well, right? So that part I'm really passionate about is yeah, you'll not always be comfortable, you'll not always know everything, so we're all figuring it out together. So thank you so much for the opportunity.
Thanks, Abhi. Now we'll invite everyone to join us on stage. So we'll give a second to set up. First of all, thank you for really insightful discussion today. But I'll start with, what if if we are to realize the full potential of artificial intelligence over the next 5 years, how do you think the industrial world would look like? I'll start with you, Andy. What do you see the potential in the next 5 years?
So I think we've all heard a lot of use cases in the last day and a half of the potential. I think we also heard a couple people kind of with this mantra that the technology is the easy part, and that there's a lot of other things in the way of us getting going. And if you're not going fast enough, if you're feeling in control, you're not going fast enough. I spent a lot of time with a lot of companies, and I look at Jeffrey Moore's Crossing the Chasm. We're still very much in the not even into early adopters days. So I think we'll see great changes in the next 5 years. I think what we're going to see is the consultants and the people with the technology and the platform getting better at explaining it and trying to package it up more to make it more simple to get started.
Anybody else wants? The other thing Avi talked about was security. And John, you have a background before GE in security. Can you talk about the scale of the problem and why is it so critical when you have so many sensors, so many computers on a plane?
Yeah, I actually don't know the answer to that problem. I spent some fair amount of time securing platforms, making sure that everything we deployed met security standards and protocols. But it's obviously it's a moving target. You have to have partners that know not just how to detect problems, but how to remediate problems very quickly. In our world, we built an Edge OS platform because we were very cognizant about security. We had to harden the platform. When you get into industrial controls, a lot of those systems are not state of the art. I mean, you're accessing things that may be 10 years old, 5 years old, 20 years old. So it's a moving target, to be quite honest. It's something we take very seriously, and we're looking at where we do monitoring and analysis versus control. And I think to get to the control piece, the security discussion has got to really come front and center.
Yeah, cool. Abhi, next question. I know you've worked on a lot of analytics projects around. So how do you see analytics and AI impacting the supply chain? Do you see it gives you an opportunity to challenge some of the OEMs? Does it threaten you from second-tier suppliers? How does it going to impact, and what are you doing to address that?
So that's an interesting question. So my responsibility in Honeywell is both internal analytics and external analytics. So how do we take predictive failure kind of a use case where we are trying to say, hey, when is something going to fail? And then also trying to apply analytics to improve manufacturing yield in our factories, right? Because we can't keep on adding capital, and if our yield is not right, we need to go improve the yield versus adding another line, right? So And I think the opportunity, and it's a tremendous amount of opportunity to really connect those two words of internal analytics and external analytics, because a lot of times people think like, oh, this is my top line, this is my margin expansion. But honestly, if you can connect those two words, you have a much bigger competitive advantage in terms of, hey, I'm predicting the failure, and at the same time, in certain aspects, I'm also providing maintenance services to the same customer. Can I make sure my part is available? And then also, can I use that as a demand planning tool to bring it into my supply chain so I can have a much better and much more accurate demand plan, so I'm actually doing my manufacturing and aligning that, as well as the whole network, right? So being able to close that loop, yeah, we are starting to work on that, but in my mind, that's a tremendous opportunity to go address.
And we talked quite a bit about autonomous systems and autonomy, and especially autonomous cars. Everybody can see it. And that will, we also talked about extracting data and data challenges. But with autonomous agents, cellular network or broadband is going to play a pretty important role. So how does AT&T is thinking about taking that opportunity? And most importantly, what technologies are you excited about? You probably have a better understanding of what the roadmap looks like, what's after 5G, what's next.
Sure.
And
so just like many of the industries here, telecom industry itself and networking itself is going through a sea change because of a lot of these technologies and the demands being put on the network. So, today it's all about getting your, Netflix from a consumer point of view, being there without interruption in high quality, right? But take that down the road, to your point, autonomous cars or other autonomous operations becomes really important. So we are fundamentally redesigning the fabric of the network. And it has many, many stages, and if you've listened to our CTO talk about it, or our CEO, they'll talk about the billions and billions of dollars of investments going into the network. And all it is, at the end of the day, the metrics come down to better and improved coverage, faster latencies, better latencies, faster speeds, and all of the use cases that will benefit from that. So in the autonomous cars, the expectation is that you will have much of a distributed network. You would have an edge network. When we were talking about edge earlier, but in this case, edge of the network needs to be smarter and faster and available for cars. So if you hit a pothole or an ice patch driving down I-35, you want to be able to tell everybody around you very quickly that there's an ice patch, 100 feet, 500 feet ahead. And to be able to do that simple use case requires tremendous amount of technology. And so, yes, the networks are not there today, but the elements of that are coming into play over the next 5 years.
cool. That's very interesting. Thank you very much, everyone, for joining. Really appreciate it. Thank you.